war and space exploration may be mutually exclusive, because if one occurs on a massive scale, the other probably will not. And you can take that either way. Anyway. Okay. So, good morning, ladies and gentlemen. I'm Jerry Stone, and I run Spaceflight UK. I am a space expert, and I can say that because that's how I get described when I go on Sky News, covering things like the launch of the Maven spacecraft to Mars. I was also interviewed by NBC, as I'm the president of the UK branch of the Mars Society. So I'm a freelance space presenter, and I give talks all over the country. I go to schools all over the country doing space workshops, and we get young people excited about science and the STEM subjects. And I'm also an author. This is my book about the moon landings, and Patrick had a copy and said it's marvellous, which is pretty good recommendation. So I have some copies here. Please buy them so I don't have to carry them home with me. So my subject today is the red planet. Let's go to Mars. We have gone to Mars lots of times. This is just the American missions, apart from the very, very last one. But you can see that getting to Mars isn't easy. Failure, 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 failure. Okay. And the latest craft to be sent towards Mars will launch this year. There are actually two of them. The first, one of them was launched on May the 5th, InSight. I covered that on Sky News. Date for your diary, November 26th. That's when it arrives at Mars. The other one was launched on the 6th of February with the first Falcon Heavy, and being the first flight and a test flight. They didn't want to risk anyone's multi-million-dollar satellite, but they did want some kind of payload on there. And as Elon Musk not only owns Spacek, but he owns the Tesla Motor Company, up it went. And when I was interviewed about that, I pointed out that there was a dummy in the driving seat. So that means it was going where no mannequin has gone before. Thank you. In the background, this is an actual photo taken from it in space, looking back at it with the Earth behind, and you can see Australia there. So what happened? The West Australian police issued a speeding ticket. Brilliant. I mean, that is class, isn't it? Okay. So this is heading in the general direction of Mars, okay? But how do we send humans to Mars? There have been various options put forward. In 1989, we had the Space Exploration Initiative. So under this, we would build the International Space Station, we would then build a lunar base, and we would then assemble in orbit around the Earth the modules of the Mars craft. And we would then go off to Mars. So we took, as it says, 1,000 tons for this thing. Total cost of all this, $450 billion. And despite having come up with that number, they actually put it to Congress. Quite right. This is an appalling way to get to Mars. So, version 2, which was announced, well, I hesitate to call him Bush II because that gives the implication that there might sometime be a third. But anyway, in 2004, he announced the new vision for space exploration. And under this, we would complete the International Space Station, retire the shuttle, return to the moon, and only after we've done that can we go to Mars. Okay. Although it didn't actually say how. Why this emphasis on going to the moon first? Well, the arguments given were, now I've actually seen this in print. Mars is 1,000 times the distance of the moon. We can practice for Mars on the moon. We can test the technology that we're going to use. We can use lunar resources. All of this is rubbish. Okay? Firstly, Mars is about 400 times the distance of the moon, not 1,000. We have better training grounds on Earth for going to Mars than possibly on the moon. There is very limited psychological value of being on the moon, where you have a day and night cycle that lasts 28 Earth days, whereas a day and night cycle on Mars lasts 24.5 hours. And on the moon, you have a black sky, whereas it actually gets light on Mars in the daytime, although the sky is pink. But anyway. And that's because the moon has no atmosphere, which is also important for reasons I'll come on to. Also, on the moon, we believe that there's frozen water, ice below the surface, mostly around the poles. Whereas on Mars, we know that there is so much ice below the surface, if it was melted and brought up to ground level, it would flood the entire planet to a depth of almost 100 meters. That's a staggering amount of water. We can test vehicles in Earth orbit. We don't need to take them to the moon. And there's the added cost of lunar operations, because once you're in Earth orbit, the energy to go to the moon or to go to Mars, there's practically no difference between. So there's no saving on energy requirements. So, probably around 20 years ago now, that the Mars Society came up with an option. So this is a worldwide organization of people who are enthusiastic about the idea of exploring Mars and developing operations on Mars. So, version 3 is Mars Direct. It's called Mars Direct because you go direct to Mars. Do not go to the moon. Do not stop to collect lunar materials, which are of no use to you when you want to go to Mars anyway. How do we do it? And what makes this different is we can do it with today's technology. We don't need to spend decades developing brand new boosters. We can just modify what we already have. The other thing is, what makes the whole thing even much, much cheaper is that the spacecraft can be launched on pretty much existing boosters. Why? Because it's not going to be a 1,000-ton spacecraft. The way you make it small and lighter and therefore cheaper and simpler is you do not take with you the fuel that you need to get back. Now, I know it sounds drastic, but bear with me. So, they proposed the Ares rocket, so Ares being another term for Mars. And as you can see, it looks rather like the space shuttle without the orbiter. Now, the orbiter had the 3 main engines, which burnt the fuel from the central tank. So we need to add some engines, but that's okay, because we've already built the engines. It's just a question of fitting them on the tank. 2 solid rocket boosters and an upper stage, which contains an unmanned return craft. This goes off and lands on Mars. Inside that is 6 tons of liquid hydrogen and equipment to combine the liquid hydrogen with the carbon dioxide from the atmosphere of Mars, which doesn't exist on the moon, and you get methane. That's the fuel that you use to lift off to come back. Now, as we can only go to Mars in very round numbers, about every 2 years, by the time the crew is sent out, their return craft is already sitting on Mars, waiting for them, fully fueled. So they land there in their hab, which is also their workshop, laboratories, airlocks and everything. And after they've completed their work there, they get into the return craft and come back to Earth. So what makes all this possible is, as Lewis and Clark would say, living off the land, using the resources of your location. In this case, it is the formula up here. So you combine hydrogen and carbon dioxide, that gives you 2 H2O, water, and methane, which goes into the propellant tanks. The water then gets broken down into hydrogen and oxygen. The oxygen goes into tanks. The hydrogen gets recycled back to the first process. And you also break down some more carbon dioxide into carbon monoxide and oxygen. So the oxygen again goes into the propellant tanks, the carbon monoxide is waste. This is not untried technology. This is the Sabatier reaction, which we've known about and used for over 100 years. Very, very simple. It's even been tested under simulated Martian conditions. So we know we can do this. So how do we go about it? You send out the first return craft. That lands and starts making methane. About 2 years later, you send out the first crew and the second return craft. The crew lands slightly ahead. There only needs to be a few days. The first thing they do is check out the return craft. And if they find that despite all the telemetry that's been coming back to Earth, that when they examine it, they find that for whatever reason, they can't actually use it to come back to Earth, you redirect the second craft to land at their location. So you have a backup, a complete spare spacecraft. But if everything's fine, that lands at a different location. 2 years after that, you send out the second crew and the third return craft, and so on. After a while, you choose one of those locations and all the next craft continue to land at the same place to build up your base. Is this viable? Well, NASA thought so. For many years, it was their design reference mission for getting to Mars. And then in 2013, the BBC asked Imperial College in London to design a Mars mission. And basically what they came up with was Mars Direct, but with one little change. Because now we know about all the water below the surface of Mars, they said, don't bother to take liquid hydrogen out. You can just drill down below the surface, put some heaters down, melts the ice, pump it up to the surface and break that into hydrogen and oxygen and use that. So if you're not taking 6 tons of hydrogen, it means you can take 6 tons more equipment, a couple of rovers that the team can use to explore when they're on the surface. Mike Griffin, a previous administrator of NASA, said in a presentation that he gave here in London that NASA concluded that following 10 years of hardware development, 9 Mars missions could be conducted over a 20-year period for a total cost of about 120 billion, or $6 billion per year, which is significantly less than we spend each year we were spending on the shuttle and the International Space Station. In fact, 6 billion a year would buy you, what, a few F-35 aircraft? Whereas instead, what do you want? A few more fighter planes, or do you want to go to Mars? It's a no-brainer, isn't it? One other way of reducing cost is to reduce the flight time. So here is Dr. Franklin Chang Diaz, who flew 7 times on the shuttle. His speciality is high energy plasma physics, and his Ad Astra company have built these demonstration plasma engines. With a full-size version of this, instead of taking 7 to 9 months to get to Mars, we could do it in 39 days. And that totally changes the entire logistics of the mission. My personal view is he should basically be giving all the funding he needs to pursue this, because the benefits back to the space economy will be absolutely vast. There are other ideas about getting to Mars. Oh dear. Inspiration Mars. I'm not sure where they got their inspiration from back in 2013. And then there was this a few months later, Mars One, or as I refer to it, Mars One Way, because the idea is you don't take the fuel for the return trip because you're not going to return. The problem with this is that once you start this, you cannot stop. You have to keep sending, if not more people. You've got to keep sending supplies. Anyone who's seen or read The Martian will know that, yes, you can grow stuff in Martian soil, but you can't eat it. The metal content will be too high. You need to modify the soil, and it will take ages before a couple of people who landed on Mars can modify enough soil and grow enough food to sustain them and be self-sufficient. So in the meantime, you've got to keep sending food out to them. And if you send another 2 people, you've got to send twice as much food. And so it's just, no, it's silly. If you're going to Mars, make sure you can come back. SpaceX also wants to go to Mars. In fact, this was an announcement back in 2011. We're going all the way to Mars, I think. Best case, 10 years. Worst case, 15 to 20 years. So that could mean we'd see people on Mars by 2031. Possibly, at the time that was said, by 2021. No, don't hold your breath for that one. But 2031, I would say even that's pushing it a bit, but who knows with someone like Elon Musk, who has announced plans to send huge numbers of people into space using his design for a big flaming rocket, capable of carrying 40 people. And in the images they released, they showed it going to the moon or Mars, which is rather interesting because you've got the same rocket going to both places, and yet one of them has twice the gravity of the other. So I'm not sure. Anyway, here's another plan. Skylar. Hands up, who knows who is developing Skylar? And where is it being developed? Yes, here in Britain, okay? Originally conceived by Alan Bond, who was the lead designer for HOTOL, which the government decided was a great idea that they wouldn't support. So this is a space plane. Unlike HOTOL, it does not need to be carried aloft on something. It takes off by itself on a runway. When it gets up to a suitable altitude, it keeps on going, right up to orbit. This is our single stage to orbit craft, the thing that we've dreamed about since the beginning of space ideas. How is it possible? Because, like Mars Direct, you're not carrying with you all the fuel on board that you need, as it would if it was purely a rocket. Instead, the engines on each of the wings, the Sabre engines, these are revolutionary. they start off acting as jet engines. So the thrust comes from air, which is pulled in at the front of the engines and heated up and blasted out the back. It's only when you get really high up that the air becomes too thin to do that. You close off the front nacelles, and they then use the onboard liquid oxygen, liquid hydrogen to act as rocket engines. So it's the same engine, it operates in both modes. Nobody else in the world is doing this. And recent studies, recent announcements have said test flights may begin around 2022 to 2024. But Alan came up with another idea. I mean, the whole point about this is it goes up, it can put 15 tons in orbit, it can take 11 tons to the space station, which is nearly 50% more than a reusable Falcon 9 can carry to the space station. But it then comes back, it lands on a runway, and after a few days of maintenance and refueling, you fly it again, and again, and again. So it's that reusability that is the key to everything as being a mentioned. You don't want to throw the thing away at the end of the flight. So, in the payload bay of that, you ferry up components for a Mars flight. So that goes off to Mars, it goes into orbit around Mars, and the conical vehicles descend to the surface, part of that comes back. Docks with this whole vehicle comes back into orbit around the Earth. So for your next Mars trip, you just need the landing craft and some more fuel. And he even came up with possible flight times. 6th of December 2028, and put that in your diaries as well. Let's see if we meet it. So, in the meantime, though, we can continue to admire the views from our robotic explorers. But in the meantime, though, the Mars Society is doing more work. We have the Mars Analog Research Stations. How long did it take us to come up with that name? So this one is in Devon Island in the Canadian Arctic. The other one is in the middle of nowhere in Utah. In fact, they even have T-shirts on it that says in big letters, "Where in the hell is Hanksville?" But these are analogues of the HABs that could be sent to Mars. So they contain living quarters, laboratories, and so forth. And teams go there usually for about a month at a time. We've had long duration missions. But what they are doing is effectively testing out procedures and activities to work out what we can do, how best to use the people's time when they're on Mars. So the one up on Devon Island was sponsored by Flashline, so it's known as F-Mars. The one in the desert is known as D-Mars. And the teams, when they go out, they wear environment suits, and they go through an airlock, which of course doesn't depress, but they do spend 5 minutes in the airlock between going in and out, and they brush each other down and so forth. So the European Mars societies got together and we designed our own version, EuroMars, which is, unlike the others, 2 steps. This is a 3-level HAB. Bigger, far more sophisticated. What we would like to do is to raise funds to build the mock-up to be placed somewhere in Europe. In fact, we had picked out a location in Iceland as being, like the other two places, analogous to Mars. So desert is like the surface of Mars. Devon Island is also like the surface of Mars. It's remote, bleak, absolutely freezing, which makes it more accurate than Utah. The problem about Iceland is simply that it's so remote and the cost of getting out there and avoiding volcanoes, of course. Personally, I think Scotland would be good. I mean, there's some remote areas of Scotland. We could do it. Or Tenerife has been suggested. So, for the long term, of course, rather than adapting ourselves to Mars, we'd like to adapt to Mars using terraforming. If we can introduce the right ingredients to the surface of Mars that will transform the atmosphere, that will take root and grow, we will increase the air pressure so that it can support water on the surface, and finally the sky might eventually change from pink to blue, and we finish up with a blue Mars. And then people here on Earth would be receiving, well, perhaps not quite like this, but postcards from their friends and family out there on the no longer entirely red planet. Thank you very much.